All right, so Unit 3, derivatives from graphs and tables. That would just be day 1. Day 2 and 3 and 4 are more derivative rules. So we don't learn another new derivative rule today. We're just going to use what we know looking at pictures and tables. The rest of the unit will learn derivatives of logs, of exponents, and inverses. And then review, and test. Not this block day, but the next block day. Okay, in AP Calculus, we often examine graphs of functions to answer questions. And again, they're usually easy in terms of computation because there's no formulas, there's no equations, but maybe difficult in terms of concepts because they're only testing do you understand concepts. So consider the function whose graph is given below. At how many values of x is f prime equal to 0? So slope equal to 0. Another way to say that would be a horizontal tangent line. So like kind of your brain needs to sort of process all of those things and then start looking at the picture. And how many places between A and B is there a horizontal tangent line? How many places do you see? Yeah, you see some hands held with 4 fingers up. I would say there's 4 places that have a horizontal tangent line where the slope is 0.
Would it not be the one on the y-axis?
Right there? So somebody answer that. Why is the slope not 0 there? It's a cusp. In fact, if you read part B, maybe you'd figure that one out. At how many values between A and B is the derivative non-existent? Well, you just called out one of them. For sure. Any other places? Let's see, non-existent would mean either a vertical tangent line, a discontinuity of some sort, or a cusp. And there's a cusp, but there's only one, so one spot the derivative doesn't exist. Part C. How many times does the sine of f prime, does the sine of the slope change? Like from positive to negative or negative to positive. How many times does it change? Let's see. Well, it starts negative and turns positive right there. Positive to negative right there. Derivative is undefined at the origin, but it still changes from negative to positive. And then a change and a change. So I think we got 5 sign changes. Again, some students like these types of questions because there's no memorizing formulas. There's no specific equations you have to know. It's just do you understand what derivative means and what slope means. Number 2, consider the function f whose graph is given. Which of the following is true? Okay, so we're just like ordering. Oh wait, I got derivatives and non-derivatives. Ugh. So I'm going to have to find all of these things and then see which one is true. F prime at negative 1. So that would be right there. So that means the slope at negative 1. What's the slope at negative 1? I think it's negative 1/2. F prime at 4. 2, 3, 4 would be right there. That one's a little bit harder to. But you look at your x value changed by 6, your y value changed by negative 6, so that's negative 1. And so part A is already out, right? Negative 1/2 is not less than negative 1. I think I'm going to go label these elsewhere here. f prime of negative 1 is negative 1/2. Negative 1/2. Negative 1/2. F prime of 4 is negative 1. I'm just labeling other places here. Uh-oh, did I mess one up? Yep, that one's not right. And the other one's not right. And the other one's not right. Yeah. F of 1. Now I'm looking at, no, F prime at 1. F prime at 1. What's the slope at 1? 1. And the function at 1. What's the function at 1? 2. Oh, maybe. 1 is less than 2. F of 3 is... F of 3 is 2. Oh, so close. Right, if only they'd thrown an equal sign under there. E is out. F of 5. 1, 2, 3, 4, 5. There's an easy one. That's 0. 0 is not less than negative 1, so...
But that's F prime of negative 4, and the first one is F prime of 4.
Uh-oh, did I mess that up again? Goodness. F prime of 1 is 1. F prime of negative 4. 1, 2, 3, 4 is right there. That slope looks more than 1 for sure, whatever it is. The y value changed by 6, and the x value changed by 3. So there's my answer. What an annoying question. I had to answer like 8 different things to finally get the right answer. I did half of them wrong along the way. Part B, if h of x is 2x times f of x, already I'm thinking product rule here. So first times derivative of the second, 2x times f prime, plus second times derivative of the first. Man, that throws people off when you have an equation to take a derivative of, just an equation name, like f of x becomes f prime, and then we have to use the graph. So there's a lot going on here. H prime of negative 4. Let's see if I can get this one right. That's a lot of pieces. So negative 8 times f prime of negative 4. 1, 2, 3, 4. We already said that was 2. F of negative 4 is negative 2. So negative 16 plus negative 4 is negative 20. Again, no equations, just all concepts. Number 3, a table. Again, no equations, just a table of values with f and g and f prime and g prime, all happening at x equals 5. Okay, if h of x is f minus 3g, well, that's an easy one, I think. H prime, then, is f prime minus 3g prime. And everything's at 5, so I'm not really worried about which line of the table I'm looking at. F prime is 2. G prime is negative 1/2. That's kind of annoying. 2 plus 3/2. Actually, safe stop, right? That's fine. 2 minus 3 times negative 1/2. Which is 2 plus 1.5, which is 3.5. But given the option, leave it alone. What will we have to do for B? what rule will we be thinking about? Product rule. So I'm a little nervous about the 2. Either leave it out front and do the product rule, or attach it to F and do the product rule. Either way. I think I'm going to attach it to the F. It's not going to matter, but so first times derivative of the second plus second times derivative of the first. And I'm leaving off the parentheses of x's because it's not really necessary and it just gums things up. Alright, everything's at 5, so this shouldn't be too bad. As long as I'm careful. F of 5. F of 5 is 6. G prime of 5 is negative 1/2. G of 5 is negative 4 times 2 times F prime of 5 is 2. And that's the safe stop, right? You've got everything there, so you're good. Negative 6 minus 16 is negative 22. But not multiple choice, so I would leave that as a safe stop. C I'm not real worried about, that's quotient rule. But D, what rule are we going to use for D? Chain rule. So H prime of X, this question was sort of on the last test. There's a multiple choice question toward the end. So start your blow pop on the outside. F prime, but leave the inside alone. And then multiply by G prime of X. This time I'm putting the X's in there because this one's a little more confusing. And yes, it's at 5, but there's something about F prime of negative 4 is 7. Somehow that matters. Maybe that matters. So let's plug in 5 for X. Let's see. G of 5 is negative 4. G prime of 5 is negative 1/2. F prime of negative 4 is not in the table, but that's why they gave it to us right here. So 7 times negative 1/2. That would be a safe stop. By the way, it would not be a safe stop with F prime of negative 4 sitting there. You can't safe stop that. You've got to plug that value in, and then you're okay to safe stop. Right, like all this is review, basically, so far. Which means, how much more of this do we need to do here? Number 4 is another table problem, although there's some tricky ones on there. Why don't I stop talking and you try A and D? B and C are a little more straightforward. You try A and D. So yeah, on number D, or letter D, H prime at 4. So let's see. F prime at 4. Found that one already. That was pi. F of 4 is negative 2. And G prime at 4 is negative 1. And that would be an okay safe stop, right? Just leave all that like it is. A multiple choice answer would clean that up a little bit. 4 pi minus 2 plus 4 would be 4 pi plus 2. But if it's not multiple choice, like, don't go any further than you have to. Again, you're not safe stopped until you plug in the pieces. You can't just leave it with the function notation there. You got to plug the values in. But once the values are in, then it's calculator ready, you're done with calculus, you can save stop that. Let's talk about E real quick. Explain why there must be at least one value of x between 4 and 6 where f prime is 0. Where f prime is 0 between 4 and 6. Well, f prime of 4 is pi, and f prime of 6 is negative square root of 5. Do you remember what the name of this thing is? IVT, intermediate value theorem. So 0 is in between, the way I drew it, the way I wrote that, it's between f prime of 6 and f prime of 4. So this is like the y values are in between the y's, so there's got to be an x value between the x's. So somewhere on 4 to 6, f prime equals 0. That's the intermediate value theorem. Okay, number 5. That was a throwback there with the IVT. 5 and 6 have the same graph. The graph of the function g is shown at the right. If f is the function given by g of x, what is f prime at 4? So another chain rule problem, g prime of g of x times g prime of x. So g prime of g of 4 times g prime of 4. G of 4 is 2. G prime of 4 is negative 1. G prime of 2, that's also negative 1. So negative 1 times negative 1 is positive 1. Why don't you try letter D? G of negative 1 is 1. G prime of negative 1 is positive 2. What's G prime of 1? Non-existent, right? Because you're at that cusp. Cusp or D and E or non-existent. And then times 2 doesn't really do anything. You're doubly non-existent, I guess. All right, on that last page, let's try just A and B, because A is chain rule, but chain rule with once with a function and like once with the name of a function f, but once with an actual function like 2x. So this is kind of weird. Table above gives values at x equals. It says x equals 5, but then that says x equals 6. So I think it needs to be, for this to work, I think that needs to say x equals 6. So the table's right, the instructions are not quite right. Okay, h prime. Let's worry about prime first, then we'll plug in so we got two things here. Autumn, how about the derivative of f of 2x? And don't plug anything in yet. Like, give me the answer without any of the values from the table yet.
That would be f prime of 2.
If you say f prime of 2, you're eating the blow pop all at once. Right? We want to go one step at a time.
F prime of 2x times 2.
There we go. F prime of 2x times 2. Okay, Dylan Autumn laid the roadmap there, so follow the same pattern for the derivative of g. Good. So that was just felt like a weird one because you don't know what f is, so you just have to call it f prime. But you can take the derivative of 2x, and then same thing with g. You don't know what g is, so you just call it g prime. But then you can take the derivative of x squared minus 3. And then plugging in 3, f prime of 2 times 3 is 6, which is good because all my x values need to be 6 in order to use that table. G prime of 9 minus 3 is 6 times 2 times 3. Is that a safe stop? No, not quite. I mean, you're almost done, but you got to plug those function values in. So f prime at 6 is negative 3. F prime at 6 is negative 3. Yes. And then g prime at 6. G prime at 6 is 2. 2 times 3 is 6. Are we safe stop now? Yeah, now we're good. Negative 6 plus 12 is 6. There's our multiple choice answer versus our safe stop answer. Let's do one more because for b, if h is the function defined by that thing, h prime, so quotient rule, but quotient rule where there's already a derivative in there, so I need to be super careful here. What's the derivative of the bottom? If the bottom is 2f prime, its derivative is 2f double prime. Oh, and this is annoying because they labeled f and g backwards from what we normally have, right? F is usually the top, g is normally the bottom. So, this would be where the high-d low, low-d high might help, I guess. So it's bottom times derivative of top. Bottom times the derivative of the top. So 2f prime g prime minus the other way around. Top times derivative of the bottom. Top times derivative of the bottom over the bottom squared. So that one was extra weird because there was already a derivative in there, so that's why a second derivative showed up, and they switched up what f and g usually are just to try to mess with us. Now we would plug in 6, and we're almost out of time, but that was the main thing of that one. Plug in 6, and eventually you'd get negative 2/3 if you wanted to find out for yourself. Okay, so today I feel like the notes take longer than the